Welcome. This is page number 51 in your notes, and we're going to get started, and I'm going to go over all of these problems and explain how I answered each one. You're going to need a set of reference tables because you're going to need to be working with table G on this set of questions. So let's get started. For question number 1, which graph below represents 4 solubility curves? Which curve represents the solubility of a gas in water? So if we have a gas, we have a gas is going to be more soluble at low temperature. So we have more soluble at a lower temperature. So that's why it's going to be choice B. So it's an inverse relationship that we're looking for a gas. A solid would have a direct relationship. So this is like on table G. We look at table G in your reference tables, right? We have the 3 gases are the ones that are the inverse relationships. All right, question number 2. An unsaturated aqueous solution of ammonia is at 90 degrees and 100 grams of water. So that's our standard amount of water over here on table G. According to reference table G, how many grams of ammonia could this unsaturated solution, so it means it's unsaturated, so 90 degrees and 100 grams of water and ammonia. So I'm going to find 90 degrees, so 90 degrees and 100 grams of water. Ammonia right here is saturated with 10 grams, okay? So I'm just going to write that down over here. I'm going to just stick with pencil. So saturated is equal to 10 grams. Oops, let me write that up at the top. Wrong question. So saturated is equal to 10 grams. So if it's above that, that would be supersaturated. 10 grams is saturated, so that's not the answer because my answer needs unsaturated, so that's going to be choice number 1. All right, so according to your reference tables, which substance forms an unsaturated solution, so not full, when 80 grams of the substance is dissolved in that 100 gram standard of water at 10 degrees Celsius? So I have to find the point where 10 degrees and 80 grams intersect. So I need 10 degrees, so that's 10 degrees, and 80 grams is right here. So if I'm looking at this point is saturated for this curve, which is sodium nitrate. So sodium nitrate would be saturated. So I'm going to cross that one out. So my point here, if I want it to be unsaturated, this point has to be below a line. The only line this is below is potassium iodide up here, right? This is the only line where this point falls below, because it's super saturated for all of these other ones, saturated on this one, unsaturated for this one. So it's going to be KI, choice number 1. All right, so number 4, according to our reference tables, which of these compounds is the least soluble in water? Okay, so this looks like we are going to be looking at table F and this one. So let's go to table F. So here we're going to look at carbonate, acetate, phosphate, and nitrate. So carbonate is over here. Carbonates are insoluble unless they're combined with a group 1 element or ammonia. So is potassium in group 1 of your periodic table? Potassium is in group 1 of the periodic table. So that makes this one soluble. So now I'm going to look at C2H3O2. So C2H3O2, soluble. Oh, no exceptions. So that one's soluble. Table F is always questions are always going to follow a 3 the same, 1 different. So now I have phosphate and nitrate. So phosphate is here. Phosphates are not soluble unless it's combined with a group 1 element or ammonia. So here I have calcium. Calcium's in group 2, so that's going to be insoluble. Now let's over here, we have a nitrate. Nitrate is soluble no exceptions. So soluble. So the least soluble is going to be the one that's not soluble, choice number 3. All right, let's look at number 5. The solubility of KClO3 in water increases as, so anytime you're stuck on a question, right, go to your reference tables, find anything in the question that looks like anything in your reference tables, and here we have this KClO3 in your reference tables. So KClO3, if I look at this line here, I start off here and this line goes up, right? And so that's going to be a direct relationship. So that means that as the solubility of the water increases, as the temperature of the solution increases. So choice number 1, direct, right? Pressure, no. Pressure only affects a gas, and this is a solid. All right, so number 6, at STP, which of these substances is most soluble in water? All right, so this is going to be, if I look at these substances, they're not on table G, so that means I need to go to table F. All right, so on table F, if I have chloride, halides are soluble unless it's with one of these 3, right? So carbon is not one of those 3, so that is soluble. Now let's look at carbon dioxide. Carbon dioxide is a gas. HCl is a gas. Nitrogen is a gas. And, oh, I see what's going on here. Okay, so this is not either table F nor table G. This means I need to look at whether or not this is polar or nonpolar, right? Because water is polar, so water can only dissolve other polar substances. So for number 6, I need to see which one is going to be polar. All right, so polar is snap, symmetrical is nonpolar, asymmetrical is polar. So if I have HCl, right, that looks like this. This is polar, so that will be soluble in water. Nitrogen is symmetrical, right? CCl4, right, if I have all 4 of the same things, symmetrical. And then carbon dioxide was this, symmetrical. My little trick that I like to use, if it ends in an even number, it is symmetrical and nonpolar. If it ends in an odd number, odd means different, different means polar, make it, it's going to be polar and asymmetrical. All right, number 7, which of the following compounds is least soluble in water? Okay, so I've got hydroxide, sulfate, chloride, acetate. This one's going to be definitely a table G. Plus, these are all ionic compounds, right? So for the most part, they're soluble in water. So chlorides, right, are soluble unless it's with silver, lead, or mercury. This is copper, so then that's soluble. Aluminum acetate. Here's my acetate. Acetates are soluble, no exceptions, soluble. Iron, Roman numeral 3, hydroxide. So I find hydroxides. Hydroxides are insoluble, except if it's with a group 1 element, calcium, barium, strontium, or ammonium. So is iron one of the exceptions? No, so that's insoluble. Now potassium sulfate. Sulfates are soluble unless it's partnered up with silver, calcium, strontium, barium, or lead. So is potassium one of those exceptions? No, so that is soluble. Again, table F questions are always the same, one different. So that if it's insoluble, it's the least soluble. All right, now let's moving on to number 8. All right, according to reference table G, which of these substances is the most soluble at 60 degrees? So at table G, the most soluble at 60 degrees is going to be the one with the highest line, right? Because that's going to be the most substance dissolved. So the highest line at 60 degrees, if I go all the way up to here, is potassium nitrate or sodium nitrate. So is that one of my choices? Potassium nitrate or sodium nitrate? No. Okay, so then now let's go down here at 60 degrees. The lowest is SO2, so that's not there. And let's go, so where's NaCl? NaCl is here at 60. right? You can't see that because I don't have that up here. This is where sodium chloride is. And the next one is potassium chloride. So already potassium chloride is more soluble. So we can cross off sodium chloride. Now we look for KClO3. So then KClO3 is down here. So that's not more soluble than our potassium chloride so far. So far, this one's the highest. So now we have to look at ammonium chloride. If ammonium chloride is higher than potassium chloride, it would be more soluble. So ammonium chloride, so here's our potassium chloride. Where's ammonium chloride at 60 degrees? Right there. It's higher, so more soluble. So there we have our most soluble. All right, according to reference table G, how many grams of potassium nitrate are needed to saturate full? Means I'm looking for a dot on the line. 200 grams of water, right? That's double the amount of water, so I double the amount of substance that I find on table G at 70 degrees. So I'm going to find where 70 degrees intersects the line for potassium nitrate. That's the saturation point. Then I'm going to multiply that by 2. So let's find 70 degrees in potassium nitrate. So 70 degrees down here at the bottom. And let's do potassium nitrate. That's going to be way, 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 way up here. Okay, so at 70 degrees, this is the saturation point in 100 grams of water, right? Because this is 100 grams of water. So if I read across, this is, I don't know, a little bit above 135. So I'm looking over here, or approximately 135. This is how much is soluble in 100 grams of water. And they're putting that there to you. I actually need to double that amount because I have double the amount of water, right? Double the amount of water, you double the amount that can dissolve. So double, oops, didn't mean to circle that, I meant to actually cross it off. I need to double 134. So that's going to be our 268. Okay, again, it comes down to reading very carefully. All right, based on reference table G, what is the maximum number of grams of potassium chloride that will dissolve, again, in 200 grams, right? Double the amount of water, double the amount that will dissolve at 50 degrees to produce a saturated solution, right? So I need the point on the line. So I'm going to go 50 degrees and find where that intersects potassium chloride, read over to see how much will dissolve, and then multiply by 2. Okay, so 50 degrees and potassium chloride. So here's my 50 degrees. I'm going to read up, up, up until I reach the potassium chloride. So it's a little bit above 40, but not quite 45, 42, 43, and then multiply by 2. Right, so then it's not going to be 42 because this is going to be saturated in 100 grams of water. So I need to do my 48 times 2. So that is going to be, sorry, 42 times 2, right? So 2 times 2 is 4, 84. Okay, there you go. Number 11. A 2-liter sample of gas has a mass of 1.8. What is its density? All right, so density is equal to mass, all right, over volume. So if I have a 1.8 and I have the volume of 2 liters, so that's grams per liter. So 1.8 divided by 2 is going to be 0.9. Okay. All right, so based on reference table G, what change will cause the solubility of potassium nitrate to increase? Potassium nitrate is right here. What's going to cause the solubility to increase? Right, so what's going to make my line go higher? Temperature, right? As temperature goes up, the solubility goes up. So temperature, increasing the temperature. Again, this is a solid. Pressure only affects gases, okay? And if I decrease the temperature, that would increase the solubility of a gas and not a solid. All right, which compound decreases in solubility as the temperature increases? So I'm looking for a gas. This is an inverse, I'm looking for an inverse relationship, right? Solubility decreases as temperature increases, right? That's inverse. So I need to find which one is inverse. I have 3 that are inverse: HCl, NH3, and SO2. And so there's my NH3. All right, so according to table G, what is the difference between the amounts of KClO3 and KNO3 soluble in 100 grams of water? So I need to find the difference between these two. And it looks like the block is over, so I'm gonna have to record this. I'm gonna have to do a separate recording for these and another time. Thank you, and I'll have to do another video.